Saxon Algebra 1, Lesson 15. This is a special bonus edition for Steffi. We're going to explore a little bit more about how to take a 3D shape and break it down for surface area. And this is kind of a confusing process because normally when we have talked about finding the area of something, it's been a two-dimensional calculation, right? It's length times width is how we find the area of a rectangle. So when it's a flat shape, like say we wanted to find the area of this piece of paper, it's a flat shape, right? It's just two dimensions, length and width, however you want to measure that. What's happening in this lesson is we're translating this idea of surface area to a three-dimensional object. And this time what I'm doing is I'm getting an actual three-dimensional object that we can look at and talk about as we do this. So hopefully, Steffi, this will help you. I've talked about it before as magic wrapping paper. And that's a metaphor that works really well for me because we want to cover each side of this. This is called it's a right rectangular prism. That's a fancy way of saying it's a box, isn't it? We can look at that and see a box. And we want to cover the ends of it, the top and the bottom, and the two sides. We want to cover every single side of it with magic wrapping paper that doesn't overlap or have any wrinkles or bubbles, right? So what we can do, though, is we can mentally take this shape and break it down into the flat surfaces, and then we can find the area of the flat surfaces. So I want to just take in my brain the visual of this three-dimensional object, and then I want to break it down into its two-dimensional sides, if you will. These planes, right? These flat areas. This is a flat area on top of here. Most people would call that the top. And I know, because I understand how rectangles are built, if I flip this over, this side is exactly the same. We're going to call one the top and one the bottom, right? But they're exactly the same size because that's how boxes operate. And we know that the shape of them it's going to be roughly like this, right? Long and skinny. That's kind of how this looks, all right? Now, we're also going to have to get these skinny sides, right? And we know that there are two of them that are the exact same. They are the same length as the box, but they're much skinnier, aren't they? We call those the sides, typically, right? There's no actual rule about that, but they're sides. And then there's one more set of faces. That's another way of describing them. These little ends. They're exactly the same, right? But they're different than these other four sides. So I'm going to call those the ends. End and end. They're the same size. They are, let's see, kind of like this, aren't they? This measurement is the same as this measurement because this is the same as on this, right? And there are two of them and they look kind of like that. I guess they're lying down, but pretend they're standing up, right? It's kind of like this. My camera's probably going crazy trying to focus on all this. I hope it looks okay. All right, so if you actually hold the three-dimensional object in your hand and think about the different sides and shapes of it, it might help you be able to break it down into the different flat surfaces that are made up here. Now, I only drew one top and bottom because they're the same size. I only drew one of these long sides because they're the same size. So I really don't need to draw the second one of these. I drew two of these for a reason that makes no sense. All right, just one picture each. Now, once we take our three-dimensional object and break it down into a number of shapes, then we can use our old understanding of how area works to find the areas of each of these, right? That's not hard. The hard part is taking a three-dimensional object and breaking it down into its flat surfaces. That's what we're trying to do. Now when we go to find the actual areas of each of these, we can refer to the picture in the book. It tells us that this side right here is 2 centimeters as our unit, 2 centimeters long as we measure it right there. Now let's see, that's gonna be part of this side, and 2 inches is also the short side of the end, right? It's this right here. So this is also 2. So I'm adding the numbers to my diagram. John tells us that this edge is 4 centimeters. Well, mine's a lot bigger, isn't it? 4 centimeters along this edge. So how do we put that on our pictures? Well, that's the long side of what we've called the side. So I would put it right here to indicate this. But it's also the same length as the long edge of our top and bottom, isn't it? So these dimensions show up in more than one side, which makes sense because all the sides are connected to each other, right? And then John tells us that, I'm trying to hold it like he does, this length is 3 centimeters. Okay, so that's the bottom of the side. It's the long part of this. I'm sorry, that's the end. It's the long part of the end, so it's this. And it's also this. 3. So that's a tricky part too, is once we have taken the three-dimensional object and broken it down into two-dimensional surfaces, then we look at the picture and take what John's information is about the lengths of the different sides, the dimensions, and we have to translate that onto our picture. If you're still confused, I would recommend that you get a box and literally cut it up. Get a cardboard box and get a strong pair of scissors and literally cut it up to see and lay out the different sides. That may help you. And wait right there. What the heck, I'm just gonna do that. I'll show you how to do this and then you can do it for yourself anytime. I'm using this block as my model, and I know that I'm gonna need to cut out one of the top or bottom, and I'm just kind of tracing around it. So now I've got the top, one of the sides, the bottom, if you will, the other side, and then I'm gonna need 2 ends. So I'll attach one here, and then we'll need one more. Okay, so I'm gonna cut out all of these pieces and wrap them around my block. When I was a very little girl, there was a TV show for kids along the lines of Mr. Rogers, but like Boomer's Edition. And the name of the dude was called Captain Kangaroo. Have you heard of it? I bet if I watched it now, it would seem really kind of creepy and old-fashioned. But in its day, I loved this show. And the captain, as we called him, would often do craft projects, little scissors and taping and gluing things. And I loved to watch him make things. And listen, I especially loved to hear the cutting sound on TV. I just thought that was the coolest. Okay, so what I've done is I have engineered for us a second, I'm just taping this last little bit together. This is an approximation of our rectangular prism, if you want to be fancy, right? I made it out of paper. Cool, right? You can do this too, anytime you want. I'll do it for some other ones, all right? And then what you can do, if you want, is take this, and we could even cut it apart, couldn't we, to see the different shapes. This is the top and the bottom. These are the two sides, and these are the two ends, as I've called them. If different words make more sense to you, that's fine. But we can see now that a three-dimensional shape, here's my three-dimensional shape again, it can be broken down into a series of two-dimensional shapes, and then we can use this to find the surface area of each one. And again, I've taken John's numbers, and it might help if we put this back in here and compare it. He says that this dimension along the front is 4. So we see we're gonna need that 4 to find the area of this, but we're also gonna need that 4 to find the area of this, because this dimension of 4 centimeters touches 2 of the sides. Likewise, on the short end, he tells us that this dimension is 2. So that's going to help us with this calculation, but also this calculation, because this is also 2. Okay? And then what else do we have? 3. This dimension is 3. Right here, 3. So we'll use it for the end piece, but we'll also use that 3 for this. And that's how I got the numbers onto here. I looked at John's picture and I visualized how they fit on my cube. Again, if you're still feeling confused, what I recommend that you do is take something like this and then cut it up into the individual rectangles so that each side of this is on its own face. Its own flat piece of paper, right? They don't need to be connected. In some ways, having them connected is confusing. It's better to cut them apart and then sort them. Put the 2 big ones together, the 2 long and skinny ones, and the 2 little flappy ones. Put them together as I did here. Notice I only drew 1 picture, but this actually represents 2 sides of our rectangle. I only drew 1 side to side. That represents 2. And I only drew 1 end piece. Oops, I accidentally drew 2, but that was confusing. That's this little end bit. What we'll do is we'll find the area of each one of these, and then we'll add it twice to represent both. So let me set this aside. So we know that the area of this, length times width, the area of one of these must be 12. The area of one of these must be 8. I'll circle the number so we know that's the area. And then the area of these 2 must be 6, just multiplying. This is the formula that we use for rectangles, right? That's the area of a rectangle. Now, to get our total surface area, we add 2 of these, 1 for the top, 1 for the bottom. So it's 12 plus 12. And then the sides are each 8, so we'll need 8 plus 8. And then these little ends are 6, so we'll do 6 plus 6. 24, 16, and 12. 52 centimeters squared. Surface area is always a square because it's still a 2-dimensional measure. I know we started with a 3-dimensional shape, but what we did was we broke that down, didn't we? We took that 3-dimensional shape and we broke it down into the individual flat shapes. We changed our calculations from 3 dimensions to 2, by disassembling that three-dimensional object and measuring just the surface of it, this is the right answer. Okay. Let's do another shape. The next one is a triangular shape. That was 15.1, by the way. I didn't write that. $15.2. Are you excited? This one makes me a little bit sad because there's a candy called Toblerone, and it used to come in a box that was perfect for describing this, but that box is no more. They went to a cheaper one. So again, I dug out my little blocks, right? These were my kids' blocks when they were little. I had the very same set, and so did my husband when we were kids. And this time, instead of breaking down a rectangular shape, we're going to introduce a bit of a triangle, right? It's kind of like half of a rectangle, which just helps us understand the way it works visually. So there's still the sides, and there's still the ends, but this top piece isn't a rectangle anymore. It's now a triangle. So we can wrap this one in paper too, and I'm gonna just quickly cut it out. You can do this yourself. I think you mentioned, Steph, that your mom was going to look at Amazon and order you some shapes. If she can order you some cardboard shapes that you can cut apart, that would be fantastic. Because you wouldn't have to do this tedious tracing and cutting out. But tedious tracing and cutting out will still work. And I think this is the right size. Okay, so bear with me as I do my Captain Kangaroo art project for you. Here comes the crunchy nails. Oh, I just loved the way the paper sounded. He was cutting construction paper. I'm just cutting graph paper, but it's pretty nice heavy paper, so hopefully you're getting a satisfying crunch. All right, so this is gonna fit around my rectangle, or I'm sorry, my triangle. Ooh, that's pretty satisfying, right? Now I have to get this side as well, don't I? I have to wrap it completely in paper. Ready? I'm gonna tape that right there. One of my daughters used to work at the Gap Kids store in my local mall. And when they went out of, well, they didn't go out of business. They closed the store, which has more to do with real estate deals than anything else I've learned. They closed their store, and so my daughter helped with closing the store. And one of the things they did, they had to get rid of all of their odds and ends. Obviously, the clothes went to other stores to be sold, any clothes that were left in their store. But all of their like office supplies, they just were taking home. The different employees were taking things home. And one of the things my daughter brought home was this tape. And it's very distinctive. It's different than the tape we get. It's shiny and it's skinny. And whenever I use it, I think of baby clothes. So there's that. Okay, look, I successfully built a paper skin for my right triangular prism. That's the fancy name for this. It just means a triangle with a right angle in it. And now we can look at this in order to see the different faces, the different sides, the different planes, there's lots of words to use to describe that, of my triangle. So now I've got it all covered. Now I'm gonna open it up. This is the magic wrapping paper that I was talking about, right? So we need to find the surface areas of all of these different parts. So I'm gonna try and name them. Let's see. I'm gonna call this long skinny piece here that matches to this, I'm gonna call that okay, I'm gonna think of it as a slide. These are the stairs. They're the straight edge, right? So this is called the stairs. And that's a rectangle, isn't it? Right here. Those are the stairs. Then the part you come down is here. That's going to be called the slide. And even though it's at an angle, it's still just a rectangular shape, isn't it? I'll show you in a second here. Right? It's kind of tilted at a weird angle, but it's just a rectangle. That's just a rectangular shape. Now, I do have this little stubby bit at the end. I'm going to call that the bottom. And it's smaller than the rest, right? It's this piece here. And there it is with my paper skin on it. Okay, so I've got 3 rectangular pieces, but none of them are the same, are they? There's the stairs, there's the slide, and then there's the bottom that's under here. They're all different. I do have some matching sides. This triangular bit here and the triangular bit on the other side. I'm gonna open it up so you can see them at once. These 2 triangles are the same. So I'm just gonna call those the triangles. And they look like this. And this time I am gonna draw 2 of them because I wanna remember that all of these I just have 1. But these I have 2 of. Okay, now we have taken our 3-dimensional shape, and thanks to our paper skin, we have broken it down into 5 different faces, if you will. 1, 2, 3, and then 4 and 5. It helps to have this in your hand to count it and look at it and understand a little bit more viscerally through your senses what it is. Okay, now I have to translate the numbers that John has given us in the picture onto this. He's told me that this edge is 4. So I can see that's going to be the tall edge here of the triangle, but it's also the long side of the stairs to our slide, right? So I'm going to put that on the long side of our stairs. Okay, what about this tipping edge? This is our slide, if you will, right? Well, John tells us that is 5 units long. So that's going to be here, but it's also on the rectangle that is the slide. So that's going to be here. It's the long edge. Okay, what about this at the bottom? It'll be the bottom of our triangle, and then also the long edge of our bottom. What number is that? That number is 3, I see in the picture. So that's 3, and it's the long edge of the bottom. Good. Now, the only number we're missing, I think, let's see, our stairs. We need this short edge, right? That's right here. What's that in the picture? Oh, in the picture, John shows it to us on this side. He says this is 6. Okay, so that means that the bottom of the slide is 6. And the bottom of the stairs are 6. And also, the other edge of the bottom itself is 6. Okay? What I see as I compare my picture to the picture in the triangle is that it would be kind of like if I put 2 of these blocks together. In fact, let me do that really fast. The actual shape that John is describing is a little bit more like this because these sides are kind of deep, all right? So don't let that throw you. It's a slightly different shape than just 1 block. Again, it's more like 2 blocks. So that's why it's kind of deeper. Okay, but this helps us visualize how the different planes fit together to make this 3-dimensional shape. Now we're ready to find the area. We know that for these are all rectangles, right? So we know that the area of a rectangle equals the length times the width, and we'll use that to do these calculations. Let's do that really quickly. 4 times 6 is 24. 5 times 6 is 30. 3 times 6 is 18. But hold your horses. Triangles have a different way to measure the area. For a triangle, the area equals base times height divided by 2. Oh, okay. So that means we have to figure out what's the base and what's the height, and we have to do this calculation. Our base is 3, and our height, let's send the spider up and have her drop the first line of her web down. Oh, it goes right straight down here, doesn't it? So the height is 4. Then we divide it by 2. Beautiful. We can reduce before we multiply. Well, let's just go ahead and multiply. Okay, 3 times 4 is 12, divided by 2, and that equals 6. So that tells me the area of one triangle is 6, but we have 2 triangles, don't we? So we'll have to add it twice. Okay, once we get from 3-dimensional object to the flat sides, I hope, Steph, that it fits together more easily in your brain. The hard part is going from 3-dimensional to 2-dimensional, I think, based on what you've told me. Okay, so now we know all of the different areas, and our final step is to add everybody together. So we're gonna add 24 plus 30 plus 18 plus 6 plus 6, right? We only have one of each of these shapes, but we do have 2 of those. All right, this is 12 and this is 12, that's 24. 2, 4, 5, 6, 7, 8. 84, and now we look and see what our units are. Meters, oh wow, that's a really big triangle. 84 meters squared, that's the right answer. Yay, beautiful. All right. Let's do the third one. This shape is called a right circular cylinder. Okay, the top and the bottom are circles, and then there's the round shape. This is the one that tends to blow people's minds the most. So let's work it out. What we see is that when we change this from 3-dimensional to 2, we're gonna have a circle at the top, yes. We're gonna have a circle at the bottom, yes. I'm gonna cut these out. Don't you dare put me on double speed. I want you to enjoy every minute of this beautiful construction project we have going on. There's one. Here's the other. One's the top and one's the bottom, but it doesn't make any difference which is which. Just like with that block, if I tell you to show me the top and the bottom, you're like, I don't know, they're the same, right? Exactly. But these 2 circles equal the top and the bottom. We're gonna put it all together in just a minute. Now, here's the interesting part. I'm going to trim off these ragged bits, and I'm gonna measure, and I'm gonna make a strip that will wrap around our purple block. Our right circular cylinder, like so, right? I'm showing you how I'm doing this because that way you can make these for yourself if you ever feel confused. Now, again, because this is magic wrapping paper, I don't want any overlap, right? Or magic wrapping paper. I want the paper just to come to a perfect seam, no overlap. Overlap is unhelpful. All right. So now we've got, let's see if I can tape this all together and make it fly. Ready? look, this exactly, I mean, pretty exactly, covers our right circular cylinder in paper, right? We've made a paper skin for it with that magic wrapping paper I've been talking so much about, right? So we have to find the area of this wrapping paper, right? So we make sure it fits our three-dimensional dude perfectly. Again, if you can buy these from Amazon, I'm gonna look and see. Steph, you said your mom was looking into that. That might really help you. If you can manipulate the paper like this, it might really help you. But see, it just barely fits. So I now have converted my three-dimensional shape into a two-dimensional paper construction. So what I have for this one is I have two circles that are the top and bottom. Doesn't matter which is which, they're both the same. And then I have what's called the lateral surface area, which is a fancy way of saying the side. Now, you wouldn't think that a round shape would translate into a rectangle, but if you look at it, it does, because we're taking what wraps around it and we're slicing that open, and now it's a rectangle. That blew my mind. I remember very distinctly the feeling I got when I first realized that this like round shape could be converted into a rectangle. But it all has to do with slicing into, it's a tube, right? If we look at it with the block not in there, we can see it a little better. It's a tube. It's an open tube. And so if we cut along one edge, then it will lay flat. Just like if you took that long skinny tube that's in the middle of, oh, like paper towels or toilet paper, it's a cylinder, but if you slice it open and lay it flat, it's a rectangle. So that's how we convert this shape, this three-dimensional shape, into two-dimensional shapes. And now we take the area of these. In order to find the area of our circle, we have to remember the formula. It's pi r squared. This will still be length times width, right? This we have to do twice, this just once. Once we look at our book, we find out that the right circular cylinder has a radius of 4 inches. Okay, so we draw that into our picture. Excuse me. Radius equals 4. Okay, we're gonna need that. And then it says it has a height of 10 inches. All right, so let's look at our paper again. The height of this shape is this dimension, which when we open it up, we realize, oh, that turns out to be the shorter dimension. This is 10. How are we gonna find that? All right, well, let's let that mystery linger for a minute. Let's go back up here. Let's calculate the area of these. It will be 3.14 times r squared, right? That's 3.14 times 16. And that equals, well, let's figure out what that equals. 3.14 times 16. Okay, so I'm just multiplying here. Multiply with me. 24. 6 plus 2 is 8. 18. And then times 1, oh, that's easy. I know it's just 314, and then we'll have the placeholder 0 there. I add 50.24. So I'm going to add, whoops, that shouldn't be there. 50.24 times, oh, wait. No, that's right. That's right. I thought I forgot to put my decimal back in. We have 2 places behind the decimal in the factors, so we put 2 places behind the decimal in the answer. 50.24, this is the top, this is the bottom. Okay, now we're back to our lateral surface area, and we have the problem of how do we figure out what that is? Well, let's go back to our picture, our skin. All right, Now, notice what's happening. When we put this circle on top and get the lateral sides into place, notice how, pretend it's perfect. The outside edge of this circle is exactly the same length as the paper that wraps around the side. Do you see how the circle and the sides fit together, right? It's not quite perfect, but it's pretty good. Those two are the same. So if we can find the circumference of the circle, right? If we can find the distance around this, that will be the same as this because they wrap around each other as they make the cylinder. Oh, that's kind of crazy, isn't it? So the circumference of that circle equals the length of this edge. So we have to find the circumference of this. What is the circumference? Oh yeah, it's pi times 2. Oh, well, that was supposed to be a 2. I'll make it an uppercase R. Sometimes mathematicians write radius with an uppercase R, sometimes a lowercase r. I tend to prefer this. It looks friendlier to me, but here I wrote it as uppercase. I'm sorry, I don't know what my brain is thinking right now. It's thinking about paper. It's not thinking about lower uppercase. All right, so we want this to be 3.14 times our radius, which is 4 times 2, because that's just how the formula works. That will be half of this number, because it's half of that. Let's just multiply it though, so you can see. 1, 8, 32, 11, 24, 25. Do you see? We multiplied 3.14 by 16 and got this number, and then we multiplied it by 8, which is half of this, and so our answer is half of that. Ooh, that's good, isn't it? That's good. So 3.14 times 8, that's the calculation for the circumference. That is the measure of this side. 25.12 is the length of this side. Now we can multiply it by the width, if you will, the other dimension, which John has so kindly put for as 10, because now all we have to do is just move that decimal place as we multiply by 10. 251.2 is the area of this rectangle. So I'm going to call that the side, because that's another name for this dimension. Lateral surface area is our fancy way of saying it. 251.2, this is where I need to see it. This was the circumference. We had to multiply it by 10. This is the number that I'm adding over here. These are all of our surface areas. Okay, to make a little chart. And then I'm going to put a 0 here because I have 2 decimal places in the other one. 8, 6, 1, 5, 3. Is that the right answer? Yay, inches squared. Okay, so we'll see this shape again and again and again. A right circular cylinder breaks down into 2 circles and a rectangle, just like we showed here. We move from 3 dimensions to 2. Okay, there's one more problem. And this is the trickiest one of all. Because in our first 3 examples, we had relatively simple shapes, right? This time, what we're going to do is look at a shape, and I had to get a little creative with this one. We're looking at a shape, let's see, it's oriented this way in the picture. We're looking at a shape that actually has 2 pieces put together. Do you see how it's a rectangle and a half circle? They're not exactly precise. They're pretty close, but they're not precise. And in John's picture, this isn't quite so long. It's kind of more like a square. Sorry, I didn't want to get out the saw. but it's a little bit more like this. My rectangle's a little too long. But in this situation, what we're going to do is we're going to have to look at these as two separate pieces. We haven't done that before. All of our other shapes were single pieces, but this one's kind of a compound, isn't it? So this is what makes this one a little harder, but we'll figure it out. And I'll tell you how we're going to do it. We're going to recognize, I'm not going to wrap this one in paper, but we're going to look at this and figure out how the different sides fit together. This side has a rainbow on it. It's, you know what this is? It's an air plant holder. I have an air plant that sits right in there. And then this is the side I usually have facing out. That's the back. Okay, so the nice thing about these shapes is because they are more complicated, John gives us a little more information. He draws a picture for us of the base. Right? So he did this. He showed us how it looks. He puts a dashed line here. I drew it solid. That doesn't make any difference. That's just style. Okay, I'm going to write in the numbers he gives us and then I'll explain what they mean. Okay, and he says the base of a right solid 10 feet high. Let's write that down. We're going to need that in a minute. Find the surface area of the right solid. Dimensions are in feet. All right, we'll use that later. Now, what we realize is that the top of the face, the top of this weird shapey thing, looks just like this, doesn't it? And the bottom of it, with my rainbow, looks exactly the same. So we're going to have two of those, right? So if we can find the area of this, we will have, let's call it the top, and then we'll have another one just like it. We'll call that the bottom. Now, we're going to have a long side that goes all the way around. It wraps around the curvy part. It comes all the way back, and it comes to here. I want you to imagine that I've taken a piece of paper just this high. Actually, I can do this without too much trouble. Let's make this as realistic as possible. I think I can do it. Captain Kangaroo is at it again. What I'm doing is I'm making a piece of paper, a strip that will wrap all the way around the edges. Just like we wrapped around that purple block a few minutes ago, right? We're gonna do it with this one, which is much longer. Let's see if this is long enough. I might need more. Yeah, I'm gonna need a little bit more, aren't I? Okay. Hang tight. Little pieces of tape sticking to my hand. Again, one of the reasons I'm showing myself doing this is because I want you to see you can do this too. You can make this. If you're feeling confused, go ahead. All right, let's see if it goes around. Beautiful. All right, I'm gonna make it so it's all the same width. You might not have any idea what I'm doing yet, but I'll show you in just a second. Okay, so now I have a long strip of paper. I'm gonna start at this back corner and I'm gonna wrap it all the way around my shape, because what I wanna do is I wanna measure this outside edge. Okay, and there's where the overlap is. I'm gonna have to trim it. Okay. So now look, it starts here and it goes all the way around. Pretend it's perfect. It's not bad, but it's not precisely perfect. But see how It wraps around the whole crazy shape. Pulling it a little bit tighter so it'll fit. Now, notice that I cut it at one corner right here, right? That's where it begins and ends. And now notice I'm creasing right there at the other corner. So when I take this off, I have a measure of this entire shape. I measured it like this. Now, this dimension here is going to be whatever this dimension is at the end of the block. Then it comes down here. Now it doesn't bend or fold, but right here at this point, I'm gonna fold it because that's where it changes from the rectangle into the circle. See how I've marked that spot? Then I wrap around some more and I'm gonna mark this spot where it changes back from rectangle, from circle to rectangle, right? Right there. I'm gonna fold it again. And those places are gonna be important in just a minute. Okay, so now I have a map of this shape. It shows me where the different sides of the rectangles are, and then it shows me the part that is going around here. So I'm gonna label them. This is the short end of the rectangle. This is the long side, end. Doesn't matter. I'm just using words that feel natural to me. I'm not trying to be mathematical. This is the part that wraps around the half circle. And then this part is once again the long side of the rectangle. And then I'm gonna just go over my creases with the pen so you can see where it changes. All right. Now, what we need to do, this is called the lateral surface area. What we'll do is we will find the lengths of each one of these segments, and then we'll be able to add them together to get the area of this whole strip. That's complicated, isn't it? But I'm gonna copy these here. This is called the lateral surface area, and it's gonna be composed of these 4 pieces. It's gonna be the long side of the rectangle. Well, as it turns out, because my shape is a little bit different, these words might be confusing, but we'll figure it out. And then the half circle. And that is that shape. And then we need the long side again. And then we'll need the short side. Okay, how do I know this? Again, we wrapped this around and we recreated the shape, the outside edge of this entire shape. Here, let me put it back here. We recreated the outside edge so that we could measure it, and we broke this down into the different shapes. Stay right there. My phone is perilously low on battery. Okay, I'm back. Thank you for being patient. All right, so what we're gonna do is, let's continue on with this calculation because we are in the middle of it. This equals what I'm calling the long side, and this is what I'm calling the short side. As the numbers turn out, they're not really long or short, but you can see that the long side is the part that connects to the rounded shape. Here, let me move it so it looks the same. What I'm calling the long side is the side that connects to the rounded shape, and what I'm calling the short side is opposite, right? So the numbers don't really tell the same story, but those are the words that I'm using, so we'll be able to use it. Okay, so to find the lateral surface area, we need the length of the long side, which equals 5. We need the length of the half circle. Let's skip over that. I want to come back to that one. We need the long side again, right? Because it wraps around like that. And then we need the short side, which is 6. Now, how are we going to find this half circle? Well, we're going to take the circumference of our circle and we're going to divide it by 2. The circumference goes all the way around. We only want half the way around. All right. So we're going to calculate the circumference. What's the formula? Pi 2r, this time I'm using a little baby r, divided by 2, because we only want half. So we see that the formula for a half circle is just pi times the radius. So it will be 3.14 times the radius, which is 3. All right? This is how we came up with that. So 3.14 times 3, let's multiply that. It's 9.42. So I'm just going to squeeze that in. And now we will add. And this comes out to let's see, this is 10, it's 16. So it's 25. I'm just adding these together. That is the length of our lateral surface area, okay? So when we look at this whole big long strip, and I'm gonna make a mini version of it here. This long side is 25.42, whatever unit we're working in. Feet, woo, that's big, okay? But what about this? This is a strip, right? And so we know how long it is, but to find its area, we also need to know this dimension. John told us way up here. He told us how high our object is, which again, it would be this dimension, how high it is, and that is 10. Oh, John, you're so nice. You choose nice numbers for us. So the total lateral surface area equals, we multiply these together, 254.2 meters squared. No, they're feet. That is the area of this strip that goes around the outside edge. It's the area of all this, right here. All of this. Now we still have to find the area of this, and we still have to find the area of that. That's what these pictures are designed to do, to remind us of that. But this is kind of a map that helps us calculate the top and the bottom. 6 times 5, well, that's 30. And then what's this? Again, we want half a circle. So we'll find, here, I need another piece of paper. I'm gonna rip it out so we can look at our picture. The area of the top or bottom is equal to the rectangle part, which is 30, and then the half circle. How do we find the area of a circle? Area of a circle equals pi r squared. So the area, and this is how I like to show it, I color in half the circle to see, oh look, I'm only talking about a half circle, equals pi r squared divided by 2. Now, when we did that in our circumference calculation, the 2's canceled out. In the area calculation, it's not as cute. It doesn't work out as well. But we can still calculate it. It's 3.14 times, what's our radius? I look back at the picture. Oh yeah, it's 3 squared. So 3.14 times 9, and that is, one nice thing about multiplying by pi, you'll memorize some of these values. 36, 12, 28.26 is this. Remember, we're dividing by 2. I need to write that every time. So it equals 28.26 divided by 2. So the area of this, I'm going to draw a little arrow because it won't fit in there, is 14.13. So when we put these two pieces together, we have to add those, right? So this is 44.13. That's the total area of these two pieces together. This is 30, this is 14.13, so together it's 44.13. But we have to add it for the bottom as well, right? So 44.13, that's the top, that's the bottom, and then the last part that we already calculated is our lateral surface area. So we take top, bottom, sides. This is our final calculation. 44.13, 44.13. Top and the bottom are the same. Lateral surface area, 254.2. And let's see if I did it right. This is oh, I see what I did. I need a 0 here, right? Because I need to line my decimal places up. I think I go a little crookedy. 3 plus 3 is 6. 3 plus 3 plus 0. 1 plus 1 plus 2 is 4. 4 times 3 is 12. I'm going to make this 5, and then I'm going to combine it with that 5 to get 10 plus 4 is 14. 342.46 feet squared. If that felt like a really hard problem to you, congratulations, you're exactly right. That was a really hard problem. Granted, I write big, but look how much it took for me to do that. And we had to go through this whole thing, right? Of understanding how the side measurement relates to the top and the bottom. We wrap it around and make sure that we understand where each one of these measurements is coming from, right? This is the short end. This is the long side. This is the half circle wrapping around like this. And then this last part is the long side, like so. Okay? If you understand it even a little bit, that's fantastic. Steph, let me know how this feels in your brain. Let me know if it helps. Let's keep talking, okay? Thank you, goodbye.